Okay, this video is going to go through the hypothesis testing questions portion of the old midterm. So this scenario is that researchers created two videos showing a very obviously bruised woman being bullied by her boyfriend. The videos are identical, except that in one video the woman was dressed provocatively, and in the other the woman was dressed conservatively. Study participants were volunteers who were randomly assigned to see one of the two videos, and then were asked whether or not they would have intervened. The results are summarized in the two-way table below. You can see among the 21 people who saw the provocative dress video, 5 said that they would intervene, and 16 said they would not. Among those who saw the conservative dress video, 23 of them there were, 13 said that they would intervene, 10 said that they would not, and we've got the totals over here. So you're going to conduct a hypothesis test to determine if the data gives strong evidence that the chance that a person says they would intervene differs depending on whether they see the video with the woman shown in provocative or conservative clothing. So we've got the null and alternative hypotheses that we're trying to identify. And remember that even though the questions are written in the order null and then alternative, you can answer either one first. And most of the time it's easiest to pick out the alternative hypothesis. Whatever we're trying to see if there's evidence to support is the alternative. So if the data gives strong evidence that the chance that a person says they would intervene differs depending on whether they see the video. Anyway, there's our alternative hypothesis. So let's fill in the alternative. The chance the person says they would intervene if the woman is higher. No, this says differs. The chance that a person said they would intervene is lower. No, the chance the person says they would intervene is the same. No, we're looking for differs. The chance that a person says they would intervene differs depending. There we go. There's our alternative hypothesis. And remember that whenever we have our null hypothesis always is a statement of equality. So when we see something that says higher, lower, differs, those could not possibly be the null hypothesis because the null hypothesis is always going to have an equality involved. So the chance that a person says they would intervene is the same whether the woman is provocatively or conservatively dressed. There's our correct null hypothesis. Question 14 asks us to write this in correct notation. Keep in mind, we're looking at two categorical variables here. And so we're interested in a difference in proportions or comparing two proportions. So my null hypothesis and my alternative would be that the P provocative and the P conservative are equal, would be the null, or that the difference between them is equal to 0, and that there's some difference, remember. So the two proportions are not the same, they're different, or similarly, that the difference in the proportions is not 0. You could write it either way. It's important to remember, though, that we do want to make sure we're writing these hypotheses in terms of the parameter, the population value, not in terms of the sample. We can look right now at the sample data, and we know whether the sample or proportions are equal. What we don't know is whether the proportion among all people in the population who would say they would intervene differs between the two conditions. Question 15 asks, if we find the results of the test to be statistically significant, will it be valid to conclude that seeing the woman dressed in provocative clothing caused the study participants to be less likely to say they would intervene? And the answer here, assuming that because we can see that the provocative is definitely the direction of the difference if it is statistically significant, the answer here is going to be yes. Right? And the reason it's yes is because the study used random assignment to the treatment groups, right? People were randomly assigned to see either the provocative or the conservative dress video. So because of that, they can make cause and effect conclusion. Yes, because the subjects were randomly assigned. Keep in mind that we don't need a random sample to make a cause and effect conclusion. We need a random sample to generalize. But we're not trying to generalize because we're only saying that the cause existed in the study participants. Okay, question 16. I'll keep my data here so that I can look at it. Among the people who saw the video with the provocative dress, what proportion said they would intervene? So right away, I know I'm only interested in those who saw the provocative dress. Whoops, I'm off the screen. There we go. There were 21 who saw the provocative dress video. 5 of them said they would intervene, so 5 out of 21 is the proportion in the provocative dress video group. Among people who saw the video with conservative dress, okay, now I'm only interested in these 23 people. 13 of them said they would intervene. So 13 out of 23 is my correct answer here. And then the sample statistic, because I'm interested in comparing proportions, my sample statistic is going to be a difference in proportions, but calculated for the sample. And I said to calculate provocative minus conservative, so I'm going to take the p hat for the provocative minus the p hat, the sample proportion, for the conservative, which I have up here. 5 out of 21 is my provocative dress. 13 out of 23 is my conservative dress. If I enter that all into my calculator, 5 out of 21 minus 13 out of 23 gives me a difference of negative 0.327. Okay. So that's my sample statistic. Doing a hypothesis test, so I'm going to need a randomization distribution to find the p-value. StatKey was used to create a randomization distribution using 200 samples. The distribution is shown below. Here it is. You can see there are 200 samples. The mean of the randomization distribution is 0.0072. The mean is 0.0072. Why is it centered around this value? Remember that the p-value is the chance of seeing our observed sample statistic or something more extreme if the null hypothesis is true. And this is why the randomization distribution is always simulated assuming that the null hypothesis is true. And the null hypothesis is that there is no difference in means, a difference of 0. So the reason that this is centered around 0 is because the null hypothesis is that there's no difference. So let's see what the choices are. Because in reality, the chance, we don't know what's reality. We only know what we saw in our data and what we've hypothesized, so that one's out. Because the sample data, in the sample data there wasn't much difference. Nope, it's not because of the sample data, it's because of the way we chose our hypotheses. Because the null hypothesis is that there's no difference in the chance that a person will intervene. That is the right answer, but let's just double check. The last one, there's no reason that it would have been equally likely to be centered anywhere. That's clearly wrong. If that were the answer, I wouldn't have bothered to ask the question, right? So, clearly wrong answer. Okay, so now we're going to use the StatKey output to find the p-value for the hypothesis test. Okay, so the p-value, remember, we're looking here at what would happen by chance if the null hypothesis is true. The p-value is the chance of seeing our sample statistic, negative 0.327, in this distribution of results. So let's see. I'm going to guess that it's about here, negative 0.327. Say, okay, what's the chance I see something as extreme or more extreme than that? Well, more extreme in this direction. There are 1, 2, 3 dots down there out of 200 samples. Let's go back and look at my alternative hypothesis, though. My alternative hypothesis isn't a less than statement, it's a not equal to statement. So really I'm looking at a two-tailed test here. So when I want to find my p-value, I'm going to multiply this by 2 because it's a two-tailed test. So that's going to give me 6 over 200. And that means 0.03. Okay, so there's my p-value. Okay, so we're going to find the answer that correctly completes the statement. The p-value is the probability that. Okay, so I know the p-value is the probability of seeing my sample statistic, or more extreme, if the null hypothesis is true. So I need to look for an answer that addresses both of these pieces. Right, so first of all, I'm only looking for things that are consistent with talking about the null hypothesis being true. The null hypothesis was that there was no difference. So anything that's talking about some difference is talking about the alternative, not the null, so those are out right away. So now I've got two possibilities. I've got there is no difference in the chance a person will say they'd intervene, whether that is the null hypothesis, but it doesn't mention the sample statistic at all. Right? So that one's not right. But just to double check, let's take a look at the last one before we circle it. Okay? The sample statistic would be as far or farther from 0 if there is no difference that, so it's talking about our sample statistic and the null hypothesis, no difference in the chance that a person will say they'd intervene. That is the correct answer. Okay. So again, p-value is the chance of seeing the sample statistic that you actually observed or something more extreme if the null hypothesis is true. This is exactly why we find it, by looking at a distribution of results that were simulated assuming the null hypothesis is true, and we start by finding our sample statistic and looking more extreme. And so those kind of piece together. For question 22, testing at the 5% significance level, what is the conclusion of the test? So remember, our p-value was 0.03. Testing at a 5% level, this is less than 5%. So we're going to reject the null hypothesis, which means that there's strong evidence in support of the alternative. So I'm looking for a statement that's going to talk about supporting the alternative hypothesis. So there's strong evidence that there is no difference. No difference is the null hypothesis, so that one is out. There's strong evidence that a person is more likely to say they'd intervene. My alternative hypothesis that I'm trying to support is that there's a difference. That is a type of difference. Right? Is it the type of difference that my data support? To judge, I'm going to look at my sample data. The proportion who saw the video with provocative dress that said they'd intervene was 5 out of 21. The people who saw the conservative was 13 out of 23. It's clearly, if there's a difference, and we saw that there is, it's that people who saw the provocative dress are less likely to say they'd intervene, not more likely. Okay, so that one should be out. There's evidence that a person is less likely to say they'd intervene if shown with this one. Looks like a good candidate to me because I just said I've shown that there's a difference, and I know the direction is in the direction of being less likely to intervene with the provocative dress. But before I circle it, I'll just read the last one. There is not strong evidence that there's a difference. Okay, that one's definitely wrong. That would be the correct only if I couldn't reject the null hypothesis. Okay, so this is the right one. Now remember, even though you did a two-tailed test, once we know that there is a statistically significant difference, it's really possible and important to always go back and tell us which direction the difference is in. Otherwise, we don't have a very useful piece of information, only, oh, there's a difference, but not knowing which direction the difference is in doesn't really help us to make helpful, sort of informed decisions about things or be able to understand the world in a better way than we did before we started. Let's see. Question 23. Which type of error might have been made? Okay, so remember there are two types of error. Type 1 error is a rejecting error. A type 2 error is an error where we fail to reject the null hypothesis when the alternative is true. So the question is, did we reject or did we fail to reject? It's always possible that we made an error with our hypothesis test. So here we rejected null hypothesis, so we couldn't possibly be making a type 2 error. We didn't fail to reject. So it's a type 1 error. Type 1 because we rejected the null hypothesis and it could be true. There's our correct answer. And then the last question in this sequence, if we were to make a 95% confidence interval for the difference in proportions of people who said they'd intervene between those who are shown provocative dress and those who are shown conservative dress video, would you expect the interval to include 0? Now remember, we rejected the null hypothesis that the difference in proportions is equal to 0. And so, based on our data, we wouldn't be wanting to reject that if that were a plausible difference. Right? So, since the hypothesis test found a statistically significant difference, 0 should not be a plausible value. Let's see, found a statistically significant difference, 0 should not be plausible. This is the right one down here. All right, so that brings us through that set of questions about the hypothesis testing scenario.